Okay, so we now introduce these two sokonalysis. So basically, this is not an introduction video. We just go straight to the point. So today I'll be demonstrating on how you can use sokonalysis 2 to actually solve RSA questions. So first of all, if you have access to the tool, you just need to run it. Just execute the tool once you have access to that. But for now, I'll provide the link when it's necessary. So these are just the testing stages. So you won't be able to have access to this tool unless you are part of Kapasa Makasa University. You can get a copy of this tool, then you can use it. But once I'm done working on it, it will be shared online. So we have a question which came in Cryptography 2023 test 1, which says using the RSA encryption algorithm, let P equal to 3 and Q equal to 5, then N equal to 15, M equal to 8, let E equal to 11, compute D. So we want to find the value for D. So in this case with the 2, what we can do, since we can see that we have option 1 as RSA, we can say 0, 1, or we can just say 1. So I'm selecting RSA in this case because we are dealing with RSA. Then the letter to number mapping, I want to use the first one, which is A1 to Z26. Okay. So once I do that, here I can say I want to find the value for D. So what I'll do, I'll just assume as if I want to encrypt something by saying E. Then it's saying enter the prime number for P, for which P in our case is 3. Then the value for Q in our case is 5. So just say 5. Then here we are given our E as 11. So just use 11. Then from that we can see that our private key or the value for D is 3. So we've obtained our first answer, which is the value for D, so is 3. So again it's saying find the code for 3. So it's more like you are encrypting this value, which is 3. So the first thing we need to do, so here just say Control C, Control L to clear. Okay, so the first thing we need to do, we need to understand what's the 3 in terms of letters. So I'll use option 9, which is a letter to number converter or number to letter converter to convert that number. So I'll use option 9. So again, I'll select the first letter to number mapping. Then here, what to do is that we use want to convert this number to a letter. So say number to letters, which is option 2. Then how many numbers you want to enter? Just one number. Then enter one number separated by spaces. So in this case, we just have 3. So you can see that 3 is C on the alphabet. So here I'll say yes to continue. So what I can do now is that since I want to encrypt these 3 with RSA, I'll choose the first option, which is option 1. Okay. Then here I'll say encrypt E, okay. So encrypt, then our P based on the question, we are given 3. Then our Q, we are given 5. Then our 11, we are given, E is 11. Then now, since we want to encrypt this value, which is 3, it's saying enter the message you want to encrypt upper letters only, so I'll say 3, which is C. So once I do that, we can see that the encrypted message becomes 12. So for us to understand what's 12, we need to convert it to letters, okay? So I know it's L, but to show, we'll just use option 9 again, which is the letter to number mapping. So say option 9, then I'll choose that letter to number mapping. So I want to convert numbers to letters, so I'll say option 2. Then how many numbers you want to enter? Just one. and that number is 12. So we can see that it's L. So we've encrypted E to be L, or C to be L, or 3 to be 12. Okay, so now we are saying decode your answer to part 2 to retrieve 3. So remember, now we want to decode. So what do we do? So we select option 1 again, which is RSA. Now this time around we'll say D to decode. Then the value for D in our case we found it was 3. Then our N we are given as 15. And then enter the number of characters in the encrypted message. Since we just have one character, I'll say 1. Then enter the encrypted message number separated by space. So the number which we encrypted was 12 for A, okay? So once I press enter, we can see that the decrypted message is C. So if you can remember, for us to convert back this to retrieve 3, we need to use option 9. Okay. Okay, so here we'll go with option 9. So 09. Remember, we've obtained C, so we want to make sure that it's 3, because we want to get back to it. So we'll say we'll convert letters to numbers now this time around. I'll say 1. So the letter we want to convert is actually C, which is 3. So we can see that we've retrieved this value. So we continue. Now coming to the 2023 test 1, we have this question which says you receive a message 17 that was sent using the RSA public encryption key, which is 21,5 of the example in this section. Decode this to find the original numeric message. So there, remember, this is the encryption key. To decrypt this, we need to have the decryption key. So again, we'll go with option 1 for RSA. Then I'm going to choose the first mapping style. Then here I'll just say encrypt. Okay. So since we have 21 as n comma e, so our n is 21, so it means p can be 3 and q can be 7, because if we say 3 times 7 we're getting 21. Okay, then from this list we can select any e we want. So in this case I'll go with 5. Then from this we can see that if we select our e as 5, even our d is equal to 5. Now that we have our private key, we can decode this message 17. So I'll say Ctrl C to cancel, Ctrl L to clear the screen. Then now again we'll start afresh with RIC. We'll go with option 1. Then the first mapping style. Okay, then this time around now we'll say decrypt, so we'll say D. Then enter the value for D. So in our case we found it was 5. Then the value for N, which is 21. Then enter the number of characters in the encrypted message. It's just 1 because 17 is just alone. Then enter the encrypted message numbers separated by space. So we can see this is 17. I'll just enter 17. Then we can see that if 17 is encrypted, it becomes E. Okay. Now the question is saying decode this to find the original numeric message. So numeric is a number. We just need to convert E into a number. So again we use option 9. So here we say 09. Then now here I'll say letter to numbers, okay, which is option 1. Then the letter is actually E, so we can see it's 5. So encrypting 17, with that private key, decrypting the letter 17, by the way. With that private key we obtained, we are getting 5 as a numerical value. So we continue. So now we have the 2023 test 2, which says using the RSA encryption algorithm, pick P equal to 11 and Q 7. Find the set of encryption or decryption keys E and D. Okay, so here what we do is that to go with RSA, which is option 1. I'll choose the first mapping style, then I'll say E to encrypt. So enter the value for P. We can see P it's saying 11. I'll say 11. Then value for Q, we can see it's 7. I'll say 7. Then here we have a list of valid prime numbers which are for E. We can select. So in this case, I'll go with the first option, which is 7. I'll just say 7. So we can see the question is saying set of keys such as E. So our E, we've decided that it will be 7. So we have our E, which is 7. Okay. Then our D in this case is 43, based on the E we've selected. So here we have now a set of the encryption and decryption keys, because this is the encryption key which we have here. Then this is the decryption key. So the first part is done. So now we are saying using the private key and the public keys calculated above, encrypt the word exam and provide its ciphertext. Okay, so we use this key, which is the public key, to encrypt the word exam. So keep in mind our E is 7, our N is 77. So for the sake of decrypting, our D, keep in mind, is 43, our N is 77. So I'll say Control C to cancel, Control L to clear the screen. Then now, since we want to encrypt, 01 is RSA. I'll use this first mapping style to encrypt the word. Then I'll say E to encrypt. So enter the value for P. You can see that P is 11. Then we can see that Q is 7. Then here we chose our E to be 7, so I'll go with 7. Then it's saying enter a message to encrypt uppercases only. So I'll say exam. Okay. So we can see that encrypting the word exam, we have this numerical answer. So if you want to view it nicely and letters, you can simply convert it. So let's do that. We use option 9 to convert. So here I will say numbers to letters. Okay, so go with option 2. Then how many numbers you want to enter. So in this case, exam was 1, 2, 3, 4. So I'll say 4. Then enter 4 numbers separated by space. So you can see 1, 2, 3, 4, and those are separated by a space, like that. So once I press enter, you can see that actually the encrypted message is UUAG. Okay, now for the sake of decrypting, since we've managed to answer this question, we'll now attempt to decrypt. So I'll go 01, which is RSA. I'll select the first mapping style. This time around I'll say D to decrypt. So our D was 43, if you can remember. Our N 77. Then enter the number of characters in the encrypted message. So the word exam was 4 characters, or UUAG, which was our cipher. So once I do that, it's saying enter the encrypted message, numbers separated by space. So I'll paste that, because these are the things we encrypted, and I'll press enter. You can see we are obtaining back the word exam. So it means this particular question, we've answered it correctly. Okay. Now we come to the 2023 test 2. Again, we are still under test 2. So it's saying you receive a message KRKCQ that will sent using the RSA public encryption key 21,5. Decode this to find the original numeric and text message. So in this case, this is the encryption key. We need to find the decryption key. So we had a similar question which had this key, and we observed that if we select our E as 5, in this case, our D also be 5. So for the sake of showing it, let me just repeat. So I'll say 01 for RSA. So if we say encrypt and the value for, since our n is 21, meaning our p can be 7 and our q can be 3, because if we say 7 times 3 we get 21, then our e we can see that it's 5, so the selected 5. So if I say 5, you can notice that actually even the private key is still 5,21, like this. Okay, so we'll use that particular thing to decrypt now. So I'll say 01 for RIC. Then here, before we even encrypt, remember our program allows us to decrypt something using numerical values. So I'll go to option 9 to change these letters to numbers. Okay, so I'll say letters to numbers, option 1. So enter the letters. We can see here we have K, so I'll say K, then we have R, again we have K, then we have C, then we have Q. Okay, so once I press enter, so we've converted those letters to these numbers. Okay, now we can decrypt. So I'll say 01 for RIC, 1 for the first mapping star. So D to decrypt, remember our decryption key is 5 for D, then our N is 21, then enter the number of characters in the encrypted message. So we have 1, 2, 3, 4, 5. So I'll say 5, then enter the encrypted message numbers separated by space. So I'll paste because we've converted these letters to numbers and we have a space there. So once I press enter, you can see that the decrypted message is actually Bible. So this question again we're done. Now we move to the exam question for 2023, which says using RSA encryption algorithm, let P equal to 3 and Q equal to 5, then N equal to 15 and M 8, let E equal to 11, compute D. So we had a similar scenario, which I believe D is 3. So let's just do that. 01 for RIC, 1 for the first mapping style, E to encrypt, then P we are given as 3, I'll say 3, then Q we are given as 5, I'll say 5, then our E we are given as 11, I'll say 11, then we can see from this that our D is actually 3. So here we've computed D. So find the encoded text for cyber, encoded text for cyber. So here we want to encrypt what um, this word cyber. So I'll say cyber. Okay, so once I press enter, you can see that we have the numerical values, but here it's saying encoded text for cyber. So what I'll do, I'll convert using option 9. I'll convert these the cipher to the text. Okay, so here I'll say first option, then I'll now convert numbers to letters, option 2. So how many numbers you want to enter? So cybers 1, 2, 3, 4, 5. I'll say 5, then I'll paste these numbers, then you can see the encrypted message is this. So we have this particular encoded text for cyber, which is this. Then now it's saying decode your answer in part 2 to retrieve a cyber as a text again. So here we'll say 01 for RSA, then D to decrypt. Remember our D was 3, then our N in this case is 15, so I'll say 15. Then enter the number of characters in the encrypted message. Remember, cyber's 5 characters. Then we paste these numerical values separated by space, and so here we are supposed to get back the word cyber, not this. So let's see how is the conversion here. So at first we obtained, okay, let me just counter check, just a minute. Okay, so in this case I believe because this word cyber, in you do it manually, at some point maybe you get exponentials, okay, then when you get exponentials you need to reduce the power to the point whereby at least you wrap around to something which is less than the letter to number mapping, which is 26. So all these values we are just wrapped around, and getting back to cyber, here we are having issues based on these given keys. So because we are still under the testing stages, I'll look into this matter and fix the issue before releasing this tool. Okay, so that's the issue. So under the developing stages, we tend to analyze issues like this. Otherwise, I had properly validated everything. So I'm surprised that this is an issue. So let's continue. We see if actually we can get accurate things with these coming questions. So we can see now we are in the 2024 test 1. So in particular, RSA cryptography system P and Q have been given as 7 and 19, while restricting E to 29. So this statement simply means we can select our E but don't exceed 29. So in this particular example, I'll just use the same 29. Okay, find the pair of keys to be used and consequently encrypt the clear text message aeroplane. So let's see what will happen now. So 01 for RSA. So 1 to encrypt. Okay, so what to do, I'll say E to encrypt. So our P we are given as, what's our P? 7. Here we are given as 7. Then our Q we are given as 19. Now we have a list of possible valid E. So we can see we can select all these numbers, but we can restrict ourselves up to 29. So we can go with 5, 7, 11, 13, 17, 19, 23, and 29 itself. So in a case maybe I want to go with 29, I'll simply say 29 in that case. So if I go with 29, it means our decryption key will be 41, which is D. Okay, so now here we can see our N is 133. So it's telling us to say encrypt the word aeroplane. So I simply say aeroplane, like that. So once I press enter, we have these numbers like that, which we've obtained. Okay, so if I want to convert these numbers again, we use option 9 to letters. I will say numbers to letters, which is 2. So how many numbers do you want to enter? So aeroplane has 2, 4, 6, 7, 9. So aeroplane has 9 characters. So I'll say 9 if I'm not mistaken. We separate them by spaces: 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are getting this as our encrypted message. Then here I'll say yes to continue. So let me just see we, if we can get back to the word aeroplane if we decode. So I'll say D to decrypt. So remember D was 41 and our N was 133. So enter the number of characters in the encrypted message. So it's 9. And then here we want to enter the encrypted message separated by spaces. So we can see we get back the word aeroplane. So now again I've noticed something. How come this question, which I believe is supposed to give us an exponential, um, is actually working out like this previous question? We had some issues to get back to cyber. So again, I feel like it's the issue of the E which was selected. Okay, let's just try to go back to this question. We'll just see something. Okay, so I'll say 01 for RSA, and then I want to encrypt. So the word cyber, here we are given P as 3, Q as 5. Okay, then since we have this valid list, here we can see that us we don't have 11, but them they have 11. Okay, so what if, let me say I choose 3, because E we just select, I just go with 3, then enter. We can see that in this case even our D will be 3, and at first D was 3 even though he was leaving. So we want to encrypt the word cyber, for which this becomes the encrypted thing, okay, for cyber. So let me see if we can decrypt. So 01 for RSA, D to decrypt, 3 as our key, 15 as our N, and then cyber as 5 characters. We separate those with space. So again we get this. So what's wrong with the word cyber first of all? Alright, so I'll look into this question to improve this particular tool so that we don't get such issues. Okay, now off to the last one, which is 2025 test 1. So you received a message which is this, encrypted with the key which is this. Find the private keys that should be used to decrypt the message and work out clear text. So here, remember, for us to actually decrypt this, we need to find first the decryption key. So I'll assume as if I'm encrypting, I'll say E, then our P, since our N is 33, it means our P can be 11 and our Q is 3. Because if we say 11 times 3, we are getting 33. So here I can select my E as 3. I'll say, okay, so our E we are given 7. So I'll go with 7. So I'll say 7. Okay, so I'll say 7 like that. So we can see if I go with 7, our decryption key D becomes 3, N33. Okay, so since I want to decrypt, I need to convert this particular, I need to convert this ciphertext to letters, to numbers. So I'll say 09 to convert, then I'll say letters to numbers, which is option 1. So the letters, you can see we have UT, LA, IKNP. So once I do that, I've converted them to numerical numbers. Then now I would like to decrypt with RSA. So I'll say D to decrypt. So our D, we realized that it was 3. Our N is 33. Okay. Then enter the number of characters in the encrypted message. So if we count here, we have 1, 2, 3, 4, 5, 0.78. So we have 8. Then we would like to paste that in the numerical value for this cipher. So once I press enter, you can see that the decrypted message is actually unlocked. Okay, so this is just a demonstration of RSA using sokonalysis, which is a tool created by me, Soko James. So thanks for watching. Hope you drop some recommendations in the comments below about RSA and what changes I can make before we launch the tool. We've also seen that we've encountered an error during one of the questions. I hope to fix them, not I hope, but I'll fix it and make sure that we deliver a quality and accurate product for you guys to help you with your cryptographic journey. So this tool will be very useful for those guys who want to learn cryptography or those guys taking cryptography. So thanks for watching and see you in the next demonstration for another algorithm once we start testing it. Thank you.